Now we need to make this class persistent by annotating this class with the annotation entity from the javax.persistent library package. Basically, we are telling that instances, objects of this class can be mapped to database table. This is called object relational mapping. Because today commonly used databases are relational database management systems. They use tables and relations to hold different logical data structures. And here in programming languages we use the objects, and we need to somehow map these objects to the database tables. In the object relational mapping, this is implemented as the class itself represents the table in the database, and the field names represents the column names. And the objects, instances of this class with the all values is represented as the entries in that table. Okay? By default, the Hibernate will look for a table with name the same as we named our class name, but we can change the table name by put another annotation, which is table from the same package, and here we just can put the table name that we want to use. Let's say we want to use the table name application user. We can't use just a user name, table name user, because it's a reserved name in the Oracle database. So let's keep it application user. You can also use a lot of different annotations. You can put the annotations on the class fields. For example, column from the same package. All basic annotations are from the javax persistent package. And then put the name for that column if you want it to be different from the Java variable names. In our case, let's keep it the same as our variable names. If there's no annotation present, then Hibernate will use the variable names as the column names by default. This is first step, and let's save it. And the next step is let's look for file named persistence.xml file, and here we need to point that class to tell the Hibernate that this class is entity, and it is basically the persistent unit that can be saved to the database. Here in the persistent.xml file, you can just hit the control space, and you see the different proposing here. We need this class tag. Inside that class, we just do the same. We copy the class name together with package, so the full name of the class. Like this. Save it, and basically that's all. Sorry, that's yet not enough, because we do not have a field here for ID column in table. The database tables usually uses the ID column to uniquely identify the entries in that table, and we need that in our entity class also. Instead of putting it here, we'll create a base class that will hold that ID field, and by extending that base entity class, we can avoid copy-paste, duplicate code snippets in future entities that we will create. Basically, this is a good practice in projects, and we will create a couple of similar generic helper classes that we will use in our application in future to organize the code in more convenient way. We only need to do it once, and then we can just use it without any problem. So let's create a new package. That will hold all our common base classes that will be used in our application, and I'll call this package commons.domain, and inside that package I'll create a new class and give it a name base entity. Finish. Let's put the Java doc here. And simple description, base entity type to hold common ID property, and this class intended to be extended, so to be extended. And by the way, here we can implement the serializable interface used both by Hibernate and by Webflow, so that we do not need to implement that interface in the future, our entities and classes that will be used in Webflow. We'll just extend that base entity class, and all the serializable interface will come from the base class. So let's generate some serial version unique ID. And here we create the private class variable with the type of long and call it ID. Now let's generate the getter and setter. I'll generate this getter and setter for ID field. Good. And we need to put the two annotations on that field to tell that this field will be the ID from the Java persistence package. And the next annotation will tell that this field is generated value. Generated value from the same package. What this basically means, this basically means that Hibernate will create the Oracle sequence on that table in the database that will generate the identifier numbers for each entry in the database table. That is for Oracle database. If it is, for example, my SQL database, then it will put the option auto increment on that column. So good, done with that. Yet another annotation we should put on the base entity class called mapped superclass. That basically means that Hibernate shouldn't create the table for this class, and that this class will be only used in inheritance. Fine, now we just can save it and let's close it. And here we can now remove that serializable interface. I guess this can be removed also. And instead of implementing serializable interface, we just extend the base entity we just created and from our commons.dom main package. And yeah, it still asks to generate serial version. Okay, not a problem. This is debug mode. Okay, let's terminate debug mode. And now this class looks like this. So we shouldn't implement that serializable interface in the future when creating entities, so that we can just extend base entity with that common ID field that is used in all entities and tables. Now we can do both things, save data to database and get data from database, which means map back from database entry to the this class object instance. In the sign up form, we can when this entity is constructed, we can pass it to EntityManager to persist that object to the database table. But we do not have a mechanism to do that. So we came to a point when we must learn what is a data access object pattern and create couple of new Java classes which will be in common use. For that purpose, let's go to the Java source folder and create new package. Close that, Java, new package. And let's give it a name, something like commons.dao. Finish. And let's create a interface here. The name generic DAO. Put the Java doc and description generic interface for data access. Okay. In Java, you can do both. You can extend interfaces, adding new method declarations, and you can implement that interface. So we create that generic DAO only once, and we'll use in our application by extending it. So we'll also create one generic implementation of that interface that we also will extend. So the data access object pattern is not something I made up. This pattern were developed under Java development community. So if you go to your browser and search for Java DAO pattern, you'll find a lot of links on what it is and how to use it in your web development application. For example, if you look in Wikipedia, Oracle. So basically, here's all you need to know about this. This looks still too difficult, too complex explanation. If we look for example, then we see something similar to what we just want to create. So actually there's various variations of this pattern. Okay, let's go back to our Eclipse and you will see how we're gonna use it. So the name of that interface is generic, not only because it is will be commonly used in our application, but also because it will use Java generic. So now I will do the thing that probably will be difficult to understand if you are not familiar with the Java generics. Then you can go to the Google and search for Java generics, and you'll find what it is and how it to use. So we want to create this interface more generic by creating generic type, and we basically allow it to accept any entity types. And we will declare a couple of methods commonly used in all data access objects. That's basically the common database operations. So return type D, which basically means that this return type is unknown by now, but will be known in the future. And also the argument T, unknown type. Basically, it is what's called generics in Java. Save operation, update operation, delete operation, T find by ID, return type list of generic type T, just method that returns all entries of past entity, and finally void flush. Save this. And now we want to create a generic implementation of that interface, implementing the functionality intended to be in these methods. Let's create another one, another Java class. This will be not interface, this will be class in the same package, where is the generic DAO interface, and we will call it Generic JPA DAO, which basically means generic Java persistence IP implementation of data access object. Finish. Provides generic common implementation of generic DAO interface persistence methods. Extend this This class is not concrete. I mean, you can't use it directly because it will be abstract class, and you still need to extend that to use it. So we put the keyword abstract. This class will be also generic type, allowing the work with different entity types. And now we're gonna implement that interface we just previously created. Generic DAO T. Yeah, it might look difficult if you are not familiar with generics. Don't worry, we just create this once and just it will not involve any generic type creation in the future in our application. So this is just for our convenience. So okay, now we want to implement those methods, but before we just define some class variables here. This will be our entity type, which will be our persistent class. Then EntityManager, EntityManager from Java's persistence package. This is just an interface from a persistent package, but the implementation will be injected, and that will be Hibernate implementation of EntityManager. There's various of implementations of this EntityManager available. So Hibernate EntityManager is one of them. And let's create some public constructor. Where we can pass the entity type. The same name. Let's generate the EntityManager getter and setter. Okay. We do not want to give access to our EntityManager from outside, except the classes that inherits, extends that generic JPA DAO. So fix this to protected, so it will be accessible only in classes that inherit this class. Extends. And set EntityManager should be public, because we will annotate it with the special persistence context annotation, so that when the application starts and we need to point where to inject this EntityManager Hibernate Manager implementation, and we do it by annotating this setter method by annotation persistent context from Java's persistence. And let's create just getter method for persistent class, because we do not want the persistent class to be set to use that method because we set it with the constructor. And following just by implementations of methods from that Generic DAO interface. So I'll speed up the video to make things go faster, and then we just will overview all the implemented methods. And here's our implementations. So all methods in our Generic DAO interface. So the find by ID method, which basically encapsulates the EntityManager find method. So it uses persistent class and entry ID as attributes, and returns that entity that it will find. And about transactional and about transactions, we'll cover this in one of my future videos. So the next is find all, which is basically encapsulates get result list from that query. It returns the list of entities, and the query is very similar to basic structured query language, but it's not. This is hyper structured query language. It is also called as Hibernate structured query language. The main difference between both is that we construct these statements keeping in mind that we work with entities, not tables. As you see here, we select X is a reference of our entity, so select X from, and here we put our persistent class name. For example, in our UserEntity case, this will be name of that class, which is UserEntity. But if you remember, we will not use the UserEntity table name in database, because we put the table name as application user. So Hibernate is clever enough to understand it, and it looks for that entity and handle the whole mapping and returns the fully constructed objects. So keep in mind that the main difference here is that we use classes when we are creating some SQL statement. We'll create our own query when we will create a user JPA DAO. Then we'll see it more in details, how to create and use the HSQL statements. So the next is a save method, which encapsulates the persist, EntityManager persist method. Here we just pass the entity. In our case, we will pass the user entity, and it will persist it to the database table. Then the update, delete with some logic inside, and flush method. So, okay, done with that. Save it, and now we can forget about it. We will use it, but we will not change something here. I mean, this will stay unchanged. So okay, close it. Okay, now let's open our Webflow definition file again, and we see that we now have at this point, when the sign up form is submit, fully constructed user entity. So we need to pass it to our EntityManager to persist it. So we have one transition here which listens for events called back to sign in, and we do not have here a transition that listens the submit button. So let's create another transition which listens for, let's say, confirm sign up. When, if successful, it will send us to the let's say authenticate action state, which will create just not now, later. And inside that we put the evaluate tag, where we evaluate expression that will persist that user entity to database. We will use a user service that will also create, and this will be a standard Java bean, and invoke method create user, passing in the arguments this user variable. And as you might guess, we need to create that user service first. Okay, let's save this and go. Okay, what is this? Okay, this is a non-existing state. We'll create it later. And let's go to our Java folder, where we will create a new package. Create new package. Call it services. Finish. Inside that we create a new interface and call it user service. Okay. Service providing service methods to work with user data and entity. In the interface body, let's declare a method that returns Boolean type, and we call it create user, exactly the same method that we invoke from our Webflow definition file. Create user, and it receives in parameters the user entity good. And let's put some JavaDoc. Parameter user entity returns true if success. Create user or persist to database, whatever. Fine, we created our interface. You should always create interfaces for your services. It's a convention. Implementing it that way, you just following the object-oriented programming principles. When you have, you can have different implementations of the same services. So keep in mind this. So let's provide the implementation for this interface. And for implementations, it's common practice to create a separate package similar to that one, but following by .implementation. So create new package like this. You can type it short. So in that package we create a class this time and call it user service. Sorry. user serves impl. Okay, click finish. Again, some Java doc. I'll just copy this. And here we implementing that interface. User serves. Let's implement that method. Now we want to put some logic here. Firstly, we want to check if that user is available, username is available, and then save it or throw an exception. So, but firstly, we'll just try to save without any validation and see if something we just created is working. So, if we want to work with database and persist the user database in this method, then we must use data access object specifically created to work with our user entity, which we will do next. So it's time to use that common generic classes that we created previously. So you will see how we use this data access object generic pattern. So let's go and create it. We will use it in our user service. So we need to create another new package, which will be package .dao. Inside we create the interface. Call it user DAO. Finish. Data access object interface to work with user entity database operations, like this. And here we must extend our previously created generic DAO, because we wanna use those methods declared there, plus new methods that we will declare in our user DAO interface. So we just combining those generic methods and our new ones in specifically for user DAO. So we extend generic DAO, and now we can pass the generic type and properly use that generic DAO. In our case, its generic type will be UserEntity from our example J2EE domain package, and serializable type will be long. Actually, we do not have to declare any new methods here because we want to just save user to database, and the save operation is provided in our base generic DAO interface. But because we will require some user-specific new operations in future, we just will create declare methods that will serve us in the future. So, for example, we will require to check if that user already is created, to avoid new user creation that will duplicate the already existing user in database. So let's declare a new method with return type boolean, and the name, give the name to that method check. Let's say available. check available with argument string user name, and let's put the Java documentation. Queries database for user name availability, something like that. Availability, okay. And return type will be true if the requested username is available. That means we can create user with that username we selected. And let's create another method declaration that will serve our needs in the future functionality implementation. That will basically retrieve the user entity from database. So the return type will be user entity, our user entity, and let's give the name like load user by user name, like this. And we need to pass again the username to that method. Returns just user entity. So let's go and implement these methods. So in the same package, we create the implementation of our newly created UserDAO interface. We create new class and give it a name User JPA DAO. Finish. And I'll just copy this. JPA implementation, whatever. And now one funny thing. Now what we will do here, we will extend Generic JPA DAO, which we previously created. Generic JPA DAO, which is abstract. Again, we tell the generic type user entity. And also implement our UserDAO interface. So you agree, this interesting structure, isn't it? Isn't it? This is basically the whole idea of that generic DAO pattern. We inherit the common methods from the generic JPA DAO and add our new methods by implementing it from our interface UserDAO. So spend some minutes and think about it. It's not too difficult. So let's look what Eclipse is trying to say us. Yeah, we need to add a constructor because our base class is abstract. And let's slightly modify this to use a default constructor. prefer to use it that way, and pass to the superclass constructor our UserEntity class. Do it that way. Okay. What else? We have two unimplemented methods from the user DAO interface. Let's click the add unimplemented methods. Good. Then I'll copy this. And let's provide the implementation of these methods. One feature I prefer to use, particularly in data access objects, is assert class from Spring Framework. Assert from org Spring Framework util package. Basically, I use the static method not null to check if passed parameter is not null, because if we pass to query null parameter, then our results might be unpredictable, and we do not want unpredictable behavior. That's why we just enforce that if the value is null, then this method not null will throw exception, which is illegal argument exception, and the application will crash, and that's what we want exactly. Next, we will execute a query. This query will be returned by EntityManager create query method. So we get that EntityManager from the base class and invoke method create query. So let's create our first HSQL query. So it starts basically similar to basic SQL statement. So we want to select count of returned. I'm sorry. What happened? I mean count of returned entries from database. We use that Oracle database function. So it is select count from, and now we will put here our persistent class name, persistent class get simple name, becoming long query. Where username equals this column means that this is parameter, and finally set that parameter referencing it username. Good. The reason why we do not use here just our class name, and we do not just hardcode it here, because the sometimes code requires refactoring, and entities can change their names, and if we will have here the hard-coded entity names, then we will be required to change all queries. So in this case, if we rename some entity, the queries will handle it properly. So next, let's just get the result of that query. So long count get single result, and we need to cast it to long because the method returns the object. And finally, we want to return the Boolean type. That's why we return an expression, Boolean expression, which is count is less than 1. Okay. So if the count returned by the query is 0, it is less than 1, then we return true. That means that username that we want to use is available, and we can use it, yeah. And if query returns something different from 0, then this logical statement will return false. That means that username is not available. Okay. Next method. Cert not null. In this method, we just return UserEntity by querying username. So initially, I will initialize UserEntity null value and put the return to user. Now we just like in previous method, create query, select user from reference, where username equals to parameter username, and let's set that parameter username. So this query basically returns the whole entity from database. It loads object to the server memory. Now user equals get single result and cast it to UserEntity. And we need to surround this in try-catch block because this method can throw the exception if the entry is not found. And this is gonna be no result exception. And here we just do nothing. I'll put the comment. Do nothing because In our case, it's just fine to return null value, because if the exception is thrown, then this variable will not be assigned any value, any object. It will remain null. So we just do nothing in exception case and return null. It's totally fine. Okay, now we create methods that we'll use a little bit later in our application. And we can start to use our user JPA DAO. Let's save this. And here in our user service, where we wanna use this method to save our user to database, we use it from Webflow. We define a user DAO in that class as a variable. And we define interface, not the implementation, but the interface following the convention. And let's create the getters and setters for this. Good. And just to test, in the create user method, we just will use the save method and pass that user entity to it. And here, by now, just return true. Later we'll implement the logic here. I think probably you will ask why to use service in the middle instead of invoke that user DAO save method directly from our Webflow definition file here. The answer is simple. You should not do that, because often we require some logic before do something with database. Like in our case, when we want to create a user, we just need to check if that user already exists. So, and the best place to implement that logic is a service. So you shouldn't implement that logic in data access objects, because the data access object purpose is just to do the operations with database, like retrieval and saving, and it should not contain any logic. So the whole logic should be in the service, for example, in our case, in our create user method, and here we can just use that user DAO to save that user. So basically this is one of the reasons why you use services, and then in services use the DAO objects. You should provide the layering. Okay, now it's time to configure some dependencies, because this user DAO will be not initialized without us saying Spring Framework that it should initialize it. So we need to go to our application context XML file, and here we want to define some beans. Let's say this will be DAO declarations, create bean, with some ID and with the implementing class. So we are creating bean for our user DAO, and the good practice is to put the bean ID the same as the interface is named. So where's our DAO? Here's our DAO and implementation. So we put the ID, the name of the interface, with a small starting letter, and here we put the implementation class with package. So we copy package and the name. So we just created the user DAO bean with that implementation. Good. And another bean we must create is, I'll put the comment here. This will be services declarations. And here we will declare a bean for our user service. So again, ID will be the user service and the implementation class and in this case we have a property in our user service which is UserDAO, which we need to initialize. In Spring Framework it's called injection, so we need to initialize this interface with some implementation, and we can do it this way. We put the tag here property and reference attribute. Here we reference that class variable name and put the reference to this bean we just created before. And that's all. That's a Spring injection. This will initialize this interface with some implementation when the application starts, when the Tomcat starts. And Spring uses this set method to initialize it, so it looks for set UserDAO method because this is private and it can be accessed only with the public method. Let's save that. Let's delete that because we do not want any errors. Let's see if this will work in our test execution. And yeah, I probably forgot to check if we have the such event in our view. So I'll go to flows and let's see, where's our submit button. Here's action sign up, so I'll change this to confirm sign up. Good. Save. And I think that we now just need to create a database table and test our example to see if something works. So I will create the SQL file in the source folder to hold all the database creation queries. New SQL file. I will give it a name database. Okay. Basically, the Hibernate is capable to create tables for you, and probably it will do that when you will create your new user. Hibernate will also create the table for it automatically. But I do not like this feature because I don't trust machines when creating some database structure, which is very important. That's why I prefer to create the tables manually. So here we just will create some standard basic SQL query statement. So create table application user with columns ID, which will be number, first name, which will be varchar2 with length of 20 characters, last name, and username, let's give the length 30 to support the long names and usernames. Finally, the column name password shall be 40. And we will need to create the constraints for a primary key and another one. Just a second. Give the constraint the name primary key, to the column ID, and the second constraint will be username unique key for column username. Is because we want to enforce that only one user with provided with particular username can exist in that table. So it will be enforced in the database level as well. It's that way is much more safer. Well, let's make the connection to database and create that table. So I'll try to remember how to do it in the Eclipse. And show view, data source explorer. Okay. Database connections. New connection. So we will use database, which is Oracle. Let's give it a name Oracle DB. Next. So we do not have any drivers. Yeah, okay. Let's point to the driver in our Maven repository. This will work just fine. Okay, let's go to our documents and to folder repository com Oracle. So we need this one. We have two versions of it. Let's use this jar file. Let's hope this will work. Delete this. Properties. Okay. So let's point to our local Oracle database. It will be XE. Database name, I think this should be our database schema. And if I remember correctly, we had the same password and user ID for it. And the driver class name is correct. I don't know, let's just try to test it and see if this will work. So now we have a driver selected, so this is correct. Okay, save password. Let's test the connection. Something wrong. Maybe we just had passwords. Password. Test the connection. Okay, fine. Ping is succeeded, and now we can connect to that database. Good, a successful connection. Let's choose the Oracle here. Oracle DB. XC connected. Save. And let's execute that query and create a table. Good. The table is created successfully. HSQL. So it's successful execution of query. And let's go to the our database Explorer and see if this actually is true. Here's it. And tables. And yeah, here's our new created table. What's inside? So we have the columns, ID, first name, and till the password. We have the constraints. This is primary key. And also we created the unique key on the username column. Okay. And let's see what's inside. It will be empty by now. Yeah, and you see that all the columns, the database doesn't have any entries right now. So let's go to our application and try to create our first user and see if it appears in our database. Compile. And let's go and start our server. Okay, server started. Let's go to sign up form. And if we try to submit the form with some errors or some empty fields, then the no create user action should be executed. That is because there's still messages with severity error exists in the faces context. So I will just try, let's say, and incorrect passwords. Password validation failed. Let's go to our database. And you see there's no user. Now let's do it in correct way. Put the password. Let's save and see what happens in database. Still no user. Okay. Let's go to Eclipse and look in the console what it says. We see that something good happened. For example, Hibernate created the Hibernate sequence and can generate the next value from it for our ID column. We also see that expression user service create user method was executed. But we do not see any Hibernate generated insert query here. I don't know, let's try again. Okay, let's just try to play with our Webflow definition file, if we find if it helps. Probably it's something here. We do not have a transition to some another state. So I will, after user creation by now, just send the user back to authentication form. So back to welcome. Let's give it a try. Okay, we're back to the application form, and let's check the database. Still nothing. I think that we should go in the debug mode to see what's happening inside. So let's restart the server in debug mode. And let's debug this method. Good. So at least we know that this method is executed, and let's see what we have in the parameters. So we have fully structured the user entity. We have a first name. We just type into our form a last name, encrypted password, and username. So we pass it to the save method, and let's see if that executes without errors. It looks like it's okay, and it looks like it persisted it to the database. Why we don't see it in our Eclipse database explorer. So it generated the value for a number for ID column, and the user DAO is also initialized by the user JPA DAO implementation. So all looks fine. Okay. Let's see if we use the correct database table. So all looks correct. So yeah, guys, this is what's called bug fixing. Usually almost 50% of the whole development process. Yet I have another idea where to put the breakpoint. Let's go to the generic JPA DAO Java class and find the method save and put breakpoint on it this time. So here's the method save, put the breakpoint, and wait. You know, guys, I think I found the cause of the strange behavior we just experienced. The reason why it looks like it persisted successfully but at the same time did not appear in the database could be a not committed database transaction. EntityManager database operations are not committed by default, so we need to commit it manually or use the Spring managed transaction, which we will do right now. So let's go to the top of the class and put the transactional annotation on the whole class, so that it will apply to all methods of the class, including the save method, which you can ensure by checking if there's an arrow next to the save method indicating that method is executed in transaction. So let's go, let's close the debug mode, so, stop the server, and recompile the project. Let's hope that will fix our bug. I'm quite sure it will fix it, but anyway. And start the server. Open our application. Go to sign up form and type some data. James Smith. Put the password and hit the sign up. Okay, let's go to the Eclipse, and yeah, cool. When you look at the log, we see that the query that Hibernate executed on our database, this should indicate that now we should have the records in the database. So let's go to our table and check if that is correct. So sample contents, and now success. Now you see that we have a new entry in database with the generated ID, and all data persisted to the table. First name, last name, username, and of course the hashed password. So very cool. Okay, let's say we need to test another case when we try to submit the invalid form. Let's add some new characters and for example enter the different passwords. So we have the error, and let's try to check the database, and we should not see any new records. And again, it's working as expected. Yeah, and this time let's try to submit the valid form. Sign up. Okay, so let's try it this way. So hit the sign up. Let's check our database. And again, we have another entry with the 26 ID, and the whole data persisted to the table. Oh, yeah. Okay, let's just for fun try to create another user. Sign up. You know, it seems like it hangs when we try to save user many times repeatedly. This could happen because we do not clean generate ID field, and we'll fix it later. Now we just can start new flow so that new instance of UserEntity is created. So sign up, go to the database table, and again we see our third user. Now we have 3 users created and persisted to our application user database table. So we end up with the successful results. I think I should commit these changes to the Subversion repository. So we'll commit. Let's put some create until the module and persist the database table. For sign up. Okay, let's look if all files are checked. Looks fine. Okay, committing. Good. Okay guys, I think this video is getting too long. I will cut this in segments and upload it separately. So we will continue in the next video. Okay.